Hello student, today we will take one more concept of a parametric function, that is a differentiation of one function with respect to another function. Suppose y is a function of y is a differential function of x, y is a differential function of x, then differentiate y with respect to x. Differentiation of y with respect to x is dy by dx. Similarly, we consider here u equal to u is a function of x, u and v is also function of x. If u and v are the differential function of x, then their derivative v with respect to x is du by dx is equal to f dash x, and derivative of v is equal to dv by dx is equal to g dash x. And then derivative of u with respect to v, derivative of u with respect to v is given by du by dv is equal to du by dx divided by dv by dx, that is, but derivative of u with respect to x is f dash x and derivative of v with respect to x is g dash x, and this is the concept of differentiation of one functions with respect to another function. Now we take example. Suppose u equal to x sin x and function v equal to tan x. This is the first example. We differentiate this u function with respect to x and v function also with respect to x. So differentiate with respect to x. So the derivative of u with respect to x is du by dx is equal to, here we use product rule of differentiation. So u and v, so u as it is, derivative of v is cos x plus v as it is into derivative of x with respect to 1, with respect to x is 1, it gives x into cos x plus sin x, and this is derivative of u with respect to x, and also here v equal to tan x, our next function. Now again differentiate this with respect to v function with respect to x, so it gives dv by dx, derivative of v with respect to x, and derivative of tan x is sec square x. Now call it first and it is second. Now by this function du by dv is equal to du with respect to x, dv by dx is equal to, from equation 1 and 2 we put the value of du by dx, means from 1 x into cos x plus sin x, and from 2 dv by dx is sec square x, from 1 and 2. So in this way we have to differentiate one function x sin x with respect to another function v tan x. Its differentiation is x cos x plus sin x upon sec square x. Now we take another example. Now we take the second example. Let y equal to first function sine inverse of 2x upon 1 plus x square and u equal to and phi equal to cos inverse of 1 minus x square upon 1 plus x square. Now here these are the sine inverse and cos inverse function. That's why we put x equal to tan theta here, and therefore theta equal to tan inverse of x. Take its inverse. Now our function u equal to sine inverse of 2 tan theta divided by 1 plus tan square theta. By using double angle formula of tan, it is 2 tan theta upon 1 plus tan square theta is the formula for sine 2 theta. Sine 2 theta, and therefore again we use here property sine inverse of sine theta. It is theta means it is 2 theta by property. But theta is here tan inverse of x. Theta is tan inverse of x is equal to 2 into tan inverse of x, u equal to. Now we differentiate it with respect to x. So derivative of u with respect to x is du by dx is equal to 2 constant as it is, and derivative of tan inverse x is 1 upon 1 plus x square. So that is 2 upon 1 plus x square is the du by dx. Now we take v. V function is equal to cos inverse of, here again we put x equal to tan theta, cos inverse of 1 minus tan square theta divided by 1 plus tan square theta, and again by using double angle formula here 1 minus tan square theta upon 1 plus tan square theta, it is a cos 2 theta, and therefore again we use here property cos inverse of cos theta, it is theta only, so it is 2 theta, and therefore it is 2, but theta is here, theta is tan inverse of x. V equal to tan inverse of x. Now we differentiate it with respect to x, and therefore derivative of v with respect to x is dv by dx, 2 constant, and the derivative of tan inverse x is 1 by 1 plus x square. It is equal to 2 by 1 plus x square, which is dv by dx. Call this du by dx equation is 1 and dv by dx is equation 2nd. Now the derivative of du by dv, or with respect to v, derivative of u with respect to v is equal to du by dx divided by dv by dx, and from 1 and 2 du by dx, it is 2 upon 1 plus x square divided by dv by dx from 2, it is also 2 by 1 plus x square, and therefore 1 plus x square, 1 plus x square, and 2 by 2 is equal to, it is 1, and therefore derivative of u with respect to phi is equal to 1, means derivative of sine inverse of 2x upon 1 plus x square with respect to cos inverse of this is 1 only. Now we take next. Now we take this third, differentiate tan inverse of x upon root of 1 minus x square with respect to sec inverse of 1 upon 2x square minus 1. Let this first function is u, tan inverse of x upon root of 1 minus x square. Here we use here substitution method. Put x equal to sin theta and therefore theta equal to sin inverse of x. So therefore our function u equal to tan inverse of x is sin theta divided by root of 1 minus x square. Tan inverse equal to root of 1 minus x square. X square means here it is sin square theta. It is sin theta divided by root of 1 minus sin square theta. By using first identity, it is cos square theta, and root of cos square theta, it is cos theta only, since identity 1. And sin by cos, it is a tan theta. Again we use here tan inverse of tan theta, it is theta only, u, but theta is here, it is sin inverse of x is equal to u equal to. Now we differentiate this u with respect to x here, and so therefore derivative of u with respect to x is du by dx, and derivative of sin inverse x is 1 upon root of 1 minus x square. Call equation first. Now we take second function is v sec inverse of 1 upon 2x square minus 1. Our function is sec. Whenever our function is sec, cosec, so you take its inverse. By again we use here property. Its inverse function is cos inverse of, take its reciprocal also, 2x square minus 1 our function is. Now put again here x equal to cos theta, and therefore implies theta equal to cos inverse of x. Now our function v equal to cos inverse of 2x square means x is here, cos is 2 cos square theta, 2 cos square theta minus 1. By using double angle formula, 2 cos square theta minus 1, it is cos 2 theta. It is cos 2 theta. Again we use property cos inverse of cos, it is 2 theta only, but theta is here, theta is cos inverse of x. Now we differentiate this function v with respect to x. Differentiate v with respect to x, and therefore derivative of v with respect to x is dv by dx, and 2 constant as it is into derivative of cos inverse x is minus 1 upon root of 1 minus x square, and it is equal to minus 2 upon root of 1 minus x square. Call this equation second. This is dv by dx, derivative of v with respect to x is 2 into derivative of cos inverse x is minus 1 upon root of 1 minus x square equal to minus 2 upon root of 1 minus x square. Now du by dv, derivative of v with respect to v is equal to du by dx dv by dx is equal to, from equation 1, du by dx is 1 upon root of 1 minus x square, and from equation 2 dv by dx is minus 2 upon 1 minus root of 1 minus x square, and this 1 minus x square 1 minus x square will get cancel. It gives only minus 1 by 2, and therefore du by dv is equal to minus 1 by 2, and this is derivative of u with respect to v, means derivative of tan inverse with respect to seconds. Now we take next. Now take this next, differentiate 3 raised to x with respect to log 3 to the base x here. Let u equal to 3 raised to x and second function log 3 to the base x. So we differentiate this function, differentiate with respect to x, we get du by dx. Derivative of u with respect to x is du by dx, and derivative of 3 raised to x, it is a exponential function. Like a raised to x, it is its derivative is a raised to x into log a. So its derivative is 3 raised to x into log 3. Call first equation. Now we take second function v equal to log 3 to the base x. We write this in this way also, log 3 upon log x. Now we differentiate it with respect to x. Differentiate with respect to x. So the derivative of v with respect to x is dv by dx. Log 3 is constant. We take the derivative of 1 by log x, that is log 3 into derivative of, we take its reciprocal, log x to the base log x, take its inverse, log x to the power minus 1. And after that we differentiate it. Log 3 into, we use here derivative of x raised to n. Derivative of x raised to n, it is n into x raised to n minus 1. So minus 1 into log x to the power minus 1 means it is minus 2. It is a minus 2, and by chain rule again derivative of log x, it is equal to minus 1 into this minus log 3 into, take its reciprocal, take this log x to the power minus 1 in the denominator into 1 by log x whole square into derivative of log x is 1 by x, and so this is dv by dx, derivative of v with respect to x, call equation second. Now dv by dx, derivative of u with respect to x is equal to du by du by dv, du by dx divided by dv by dx is equal to, from equation 1 du by dx, derivative of u with respect to x is 3 raised to x into log 3 divided by dv by dx from equation 2 is equal to minus 3 minus log 3 into 1 by log x whole square into 1 by x. Here log 3 will get cancelled. There is only minus 3 raised to x, take its reciprocal, into x into log x whole square, and this is du by dv derivative of u with respect to v means derivative of 3 raised to x with respect to log 3 to the base x here. Now take next, differentiate x to the power x with respect to x raised to power sin x. Here the both functions are like x to the power x means function of the function of the another power function. So let u equal to x to the power x and v equal to x to the power sin x. First of all, we take log on both sides. Taking log on both sides. So it gives log u equal to log of x to the power x. Use here log of m raised to n, it is m log n means x log u. Now we differentiate it with respect to x. We get here u into v. We use the product rule of differentiation. So derivative of log u with respect to x is 1 by u into du by dx is equal to, first function has derivative of second, so its derivative is 1 by x plus second function means log x as it is into derivative of x with respect to x means 1. It gives 1 plus log x. Now take this u in the right hand side. It is du by dx is equal to u into 1 plus log x. But u is here our original function, x to the power x into 1 plus log x. This is du by dx. Call this equation first. Now similarly we take v function. V equal to x to the power sin x. Here again function is the power of another function, that's why taking log on both sides. So it is log v is equal to log of x to the power sin x. Now again we use here rule of logarithm, log m raised to n, it is m log n log m means sin x into log x, it is a log v. Now again we differentiate with respect to x. So derivative of log v with respect to x is 1 by v into derivative of v with respect to x is dv by dx. Now we use here this sin x, and sin x is u and log x is v. Again we use u into v means product rule of differentiation. U as it is means sin x as it is into derivative of v means derivative of log x is 1 by x plus v as it is means log x as it is into derivative of u means here derivative of sin x is cos x. Now take this v in this side, it is dv by dx, it is sin x divided by x plus cos x into log x. Call this second. Now therefore du by dv is equal to du by dx divided by dv by dx is equal to, from equation 1 du by dx is here write down the value of phi is x to the power sin x, and this bracket sin x divided by x plus cos x into log x as it is. We call this equation second. Now this du by dx from equation 1, du by dx is x to the power x into 1 plus log x, x to the power x into 1 plus log x, and dv by dx is equal to x to the power sin x into sin x upon x plus cos x into log x. Now we simplify this. Here x to the power x into 1 plus log x as it is, x to the power sin x into, we simplify, multiply this, it is sin x plus x into cos x into log x and whole divided by x. Take this x, it's reciprocal, so that's why here it is x to the power x, and when we take it, it's reciprocal. This x into denominator, its power is 1, and then into x to the power 1 means we add here plus 1, and again x, take this x in the numerator, its inverse, x to the power minus sin x, that's why it is a minus sign, because its base is also x, that's why we write x to the power x plus 1 minus sin x into 1 plus log x divided by, here only in the denominator only, sin x plus x cos x into log x, and this is du by dv, means derivative of u with respect to v, hence we have to differentiate this x to the power x with respect to x to the power sin x, and its derivative is here. Now in this way we complete question number 4 of exercise 1.4, and also we complete exercise 1.4. Now today we will stop here.